Okay, I just came across this question posted on Wyzant Ask an Expert almost a year ago, which hasn't been answered. I thought I'd answer it since I do have a Desmos graph that depicts what's happening. Limaçon is of the form a plus or minus b, either sine of theta or cosine of theta, where a and b are greater than 0. And the ratio between a and b determines the type of limaçon. And in this case, a and b both equal 3, so the ratio of a to b is 1, 3 over 3. And that means we have a cardioid. Okay. Now I'm going to share my screen and go to Desmos and not display everything about that can happen on this graph, but some of the things. So there's the original equation. Oh, actually, this is cosine of theta. If I want to toggle and go to sine of theta, there's what 3 plus 3 sine of theta looks like. Ratio is 1. And if I want to advance to show points on this cardioid, how it's traced out, there when the angle is 0, this is 0 pi or 0, there's r is 3. If I keep advancing, you can see how the point is tracing out the cardioid. If I want to check for symmetry about one of these axes, if I click this one, for example, well, you can see it's not symmetric about the polar axis, which is this guy right here. Otherwise, this purple dot would be on the curve. But if I say symmetry about theta equals pi over 2, which is this vertical line, that purple dot is on the curve. And if I continue advancing, you can see that that purple dot remains on the curve all the way around. Okay. If I change the values of A and B, I can get different cardioids, or different limaçons, I should say, convex to having an inner loop. And of course, if I toggle, I can go to cosine. Of course, I'd have to symmetry about the polar axis. If I move B to a negative value, the cardioid moves over here, or the limaçon moves over to the left. Okay, so I'll stop sharing there and go back to Wyzant, and we'll talk about how to do this algebraically. So if I want to show that the curve is symmetrical about the polar axis, I have to substitute negative theta for theta, see if I end up with what I started with. So here's theta. I'm putting in negative theta for theta using this identity right here. The sine of negative theta is equal to the negative sine of theta. If I simplify this, I get 3 minus 3 sine theta, which is not the same. Okay, but if I want to check for symmetry about the vertical line, theta equals pi over 2, I have to put pi minus theta in for theta. So here's theta, here's pi minus theta, using the identity for the sign of the difference between two angles. Sine of pi, cosine of theta, minus cosine pi sine theta. Sine of pi is 0, so this term becomes a 0. This is a minus sign here. The cosine of pi is minus 1, so minus a minus 1 is plus 1. And we get what we started with. So this original curve is symmetric about the vertical line, theta equals pi over 2. Okay, if I share my screen again and answer the question, what is the difference between this curve, 3, 3, sine of theta? Let me do a reset. And the curve 8 plus 3 sine theta, well, I guess the primary difference is that we have a convex limaçon. There it is. No loop. It doesn't look like a lima bean. Let's see, what was the original question? Oh, it's cosine theta, though, see? So if I go back here and toggle this to cosine, the graph flips 90 degrees. And if I change this back like this, you can see we start to get an inner loop right there because of the ratio change. But if I leave it at 8, so there's the two primary differences. The graph is rotated 90 degrees, and we have a convex limaçon. I think it's called convex. Yep. Those are the two major differences. Okay, there you go. Hope that helped. If you have any questions, post a comment.